Morning, guys. Eric in the alley again. First off, let me wish everybody Happy New Year. Hope it's going to be a great year. Last one was pretty good. Always looking forward to the future. Today, I'm just answering a couple questions I had from viewers. One, it was from KDK, I believe. He said, ask what specs a tablet you need to run Hscope. I personally use an S6. It had a cracked screen, so it made a good garage tablet. It's still I never gave the tablet much consideration. It is using some of your tablet to process things and to save and you get your touch screen. So you do need a certain amount of in your math channel. There's a lot of you need some power. I have ran it on A7's Samsung. It's a 3 GB tablet, but Martin recommends 4. So it was basically, how cheap of a 4 GB tablet I could find. And I got one free for reviewing it actually. So I'm going to have to leave a link. Anything that you do review on or that you do receive free, you have to leave a link in the comments. So I'm going to put the link down there. I'm not saying go ahead and buy it down there, but it's just protocol, something you have to do. So it's a $60 tablet. It's a straight Android. There's no name on it. Let me show you. There's just a squiggle and it says Android. It costs $60. It's pretty decent. Fill-in tablet. It got a glossy screen. This isn't a tablet review. This is seeing if we could run a Hscope on a $60 tablet. So that's what this is going to be about. The only variable is the only thing I have in the garage at the time is the back alley bulldozer. Let me flip it around. It's this quad with a plow on it. Now, you could hook an oscilloscope up to anything. The main function of this is going to be to see if the scope runs it. I dug out a couple leads, just put it through a couple paces. Note, we're not really diagnosing the quad. I could tell you the carburetor needs built, but there's things you could do. We're going to use an amp clamp. You're going to use a homemade pulse sensor. We're going to use HT25. The HT25, if there's a miss, like if there's a spark going into the block outside the cylinder, this knocks Android off. This is a very problematic pickup for Hscope, but that's only if you have a spark occurring. Now, this thing, it might, but it's only a 1-cylinder. So some of the tests aren't going to be relevant to a car, but we're just seeing if Hscope will keep up on the $60 tablet. Or let me rephrase that. If a $60 tablet will keep up with Hscope. Okay, I set up around the battery just like we're doing an RC test. Now, the only thing is that this is a 1-cylinder. So we're not going to be comparing anything. This would be just seeing if Hscope is going to work good on this tablet. I'm hooked up the battery voltage on channel 1. Then I have a high amp clamp around the positive terminal. Now let's flip it over to the scope, get you a good view, and just do it like we're doing an RC test on a car. Only we're going to give it something simple to start with. All right, guys, this is the first time we're going to use it. And open up Hscope, it installed fine. There's no problem, just like every other tablet I used it on. So right now would be in oscilloscope mode. Device not connected. If you look down here, it should say the HS512. Hey, there it is. Okay, it goes right up. We're right at battery voltage. Battery's a little bit low. The green is the amp clamp. I'm going to just keep it right here and just bump the throttle. Make sure I'm getting a signal. Bump the starter, rather. All right. I'll go with that. Now we'll go make sure our scales are right. For channel 2, we're going to want to go way down. Run at 3.3. I'm going to go to 1.1 because it's 1 milliamp per, or 1 millivolt per amp. So this would go up to 1100 amps. This quad's not pulling that. I'm going to hit the automotive module. Going to keep it at 150, 20 milliseconds. That's fine with me. Now I'm going to just crank it. You can see on the bottom we did get a waveform. Okay, and you'll see, and this is just an Hscope trick if you don't know, not a trick, but just how you do it. You see the little bump? We should be seeing something this big. If you hit the eyeball, sometimes it'll make it bigger for you. Then you get a little bit better view of it. But if you still wanted to make it the same size, if you hit channel 2, you could just, make it the same size. That's how I used to look at them anyways. But this is a pointless test. We see the compression humps, but it's only one cylinder. You have nothing to compare it to. But the tablet's doing pretty good on that. If you were looking at the compression humps, you would put a low pass on it. Just makes a little bit, well, I put on high pass. Now you see why I usually use a mouse. But those would be the kind of compression humps that would give you, you could still do measurements. I mean, it's responding very good. I mean, no difference between the Samsung. Actually, if you see any, look how low that battery did, 5.89. If that was a car battery, it'd be coming out. But if you see any of my videos, the screen seems to, every time I touch it, it wanders to the left or right. Maybe it's too sensitive, but this seems, it's doing pretty good. All right, we're going to just move on to something else. Like I said, that was pointless. We don't want to waste no time on it, just seeing if the scope is capable. Or the tablet. I keep saying scope, the tablet. All right, next, every time you break out a scope, it doesn't matter what it's on. If you're trying to research something you're doing or using a homemade sensor, anything's a learning experience. But going into exhaust with a pulse sensor, I was going larger. And one of the problems is using a pulse sensor in the exhaust is it likes to get, whenever you accelerate, do a snap throttle, it'll blow something even as heavy as this rubber hose. It'll blow it straight out the pipe. I was thinking of different ways of clipping it on, but the best I came up with was putting a brass fitting here so I could put a clamp or a set of vice grips right on that to the tailpipe. Now, one of the viewers, Paulie D, he said he was messing around, which is weird. My wife loves Jersey Shore, and even our palm tree she named Palmy Tea. Yeah, here's probably a picture of it. But no, he said he was experimenting with using brake tube, and he was getting a pretty good waveform. So, it's anything. I was looking the total wrong way. I was going bigger, and I intended on making another pulse sensor with a bigger tube. This is just PVC and a piezo sensor. So I'm going to make a video of doing that. I have two, an identical one. I didn't assemble it yet, but just to, show you how you can make a homemade pulse sensor, and they do work very well. But you're always experimenting with the end tube, what works good. I would build another one, keep one for vacuum and one for exhaust, just experiment with the different size brass fittings, the different size hoses. So I'm going to just try that, give that a shot, because one thing about this is metal. You can vice grip it right to the pipe. That's a plus. Let's see what it does, guys. Okay, guys, let me show you what I got going on. I got the HT25 going to the spark plug wire, and then in the back, I'm just going into the pulse sensor. I got on a little bungee cord for isolation. Going through the hose, and I just got it clamped with a pair of vice grips right to the tailpipe. We'll see what kind of waveform we get with this. All right, I'm going to zoom you in. I'm going to start up Hscope again. This is oscilloscope mode. I'm going to shut off channel 2. That's the pulse sensor. I just want to see what the ignition looks like on single channel. We'll keep it on 150, 1 volt. This is HT25. Okay, we're getting a pattern on it. All right, whenever we zoom in, what can we tell about this already? See how many kilovolts these two are taking, and this is taking hardly any. We could tell being this is a one cylinder, it's waste spark. It's not timing this spark. It's shooting every 2 strokes. This is the exhaust. And look how low the KV is. That's because there's no compression. These two with the higher spikes, that's what's doing the actual compression firing. This one's just firing on the waste. So real quick with a scope, you could tell some things. Checking the ignition. See how that's going straight down? The firing line's going straight down. It should have a lean uptick on it. It has a tiny one on the end, but that's what a rich ignition is. This is your firing line. It's still fired. She's running rich. Now I turned on channel 2. That's the pulse sensor. I moved over to the automotive module. Pulse sensor, I'm keeping at 3.3 volts. And we'll go with 20 milliseconds. Now we're on 10. You're going to hit record. See all the data in the bottom. Give her a snap. All right, now see when you go back, you could see everything. Then you're kind of reinforcing the waste spark. Well, first off, with a pulse sensor, we're going to put a filter on that, get a better look at it. Put a low pass on, and we'll take that down to 33 hertz. And you see the pulses. Now on a 4-cylinder, you'd count down 1 pulse. So this is a 1-cylinder. So I imagine right after the bang, you could tell the ones with the higher KV spikes, those are actually firing here. And this is the exhaust pulse. See how low this spike is? And it's right where that exhaust pulse is. So, I mean, we're only timing a 1-cylinder, but it's still pretty cool. You could tell something's waste spark without even doing any research. But on a small engine, you should almost expect it, especially if it's carbureted. If it's fuel injected, it's different. But a downward tick, you like to see a nice lean uptick. That means it's burning all the fuel. And the brake line, I mean, it does pretty good. I mean, those are usable pulses. If you had other ones to compare them to, you'd be able to tell a missing one or high one. You'd be looking for a low one, but all in all, that does pretty well. Let me shut off channel 1 so we could see it a little bit better. Those would be your exhaust pulses coming out of that brake line. It's pretty easy to clamp onto the pipe. It's a little bit easier than the bigger hose, but let's just see what the difference is. I'm going to switch over to the bigger hose if I could get it in that little pipe. That might be a little difficult, but that's what scopes are for. We're doing a little bit of research. So next time we use it on a car, I don't have to do this then. So there's never a waste of hooking up a scope. You're always going to learn something. Even the acceleration's pretty decent with the pulse sensor. And that did the job all right. All right, now I'm going to go around the back and try to hook up the bigger hose. Oh, guys, sadly, I can't hook up this one to compare it to. This is the same size as the actual exhaust pipe. And I would need the clamp here to hold this in there. So it seems like this little brake line, would have been the right thing to use on this. Okay, guys, being that the hose was a no-go, I just want to see some of the other features, just, see how they work on here, make sure they're all here. There's your cylinder identifiers. And everything works pretty smooth. The flicking them off the screen doesn't seem to work as smooth as the Samsung. Usually when you're done with it, just like that, it worked pretty good there, but it's not quite as sensitive. Your stroke identifiers. And we know we got our cursors. What else can we check out what it has on? The math channel. I mean, it's there. Oop, turn it off again. So the math channel is there, inverted. We have everything down here. We could save a signal, saving it to the tablet. Pretty smooth. Now we'll go to open it up. Here's our waveform back. I'm sure even the settings, they're on 1 dp. Let's take them up, put them on 3, see what that looks like. Thicker lines. Yeah, everything's it's identical. You could change the screen color also. Let's make sure the screen responds. We'll go with white. This thing runs pretty good. I mean, there's almost no difference other than the sensitivity of flicking a channel off, but it does respond and moves good whenever you select a channel. You could see it up in the corner. I'm selecting it and you can move it. That it works good on flipping on Hscope. When you're done with something, like we'll just put the degree rollers on. When you're done with it, usually it's press and flick, and it doesn't seem to know where the end. I'm so used to doing it on the Samsung, it would have flicked right off. So it's a small inconvenience, but definitely worth noting. See, there he went. Took a couple times. If you use a mouse, I'm sure it's a lot easier. I think the tablet just can't detect because it has a little bit higher case here. It don't know when I'm getting to the end. Oh, also, guys, one more thing I wanted to check. Let me shut the pulse sensor off. I'm going to just keep it on ignition. We'll go like standard 20, Pete Mary rule. And then what I'm going to do is run it and just take a look. How much time you got? 6 minutes and 24 seconds. This will record for. That's another question people always ask about is that how long it will record. 6 minutes and 24 seconds on that one channel. Let's just see if it changes whenever we put on channel 2. Six minutes, 24 seconds. So it's pretty decent. Let me zoom you right in on the record limit. It'll change with your sampling rate. If you wanted to go to 300, you got 3 minutes and 12 seconds. That's a pretty fast signal. I mean, if you want that much resolution for ignition, I was using the 150, 624. If you're looking for something very slow, we'll say 19 because some of them are usable. 25 minutes. If you're looking for a dead miss, you got 25 minutes to hit that and go. So that's pretty decent. Okay, while we're on the subject, I'm going to just show you what 38 kilosample a second looks like. Remember, you got 25 minutes. All right, if you had all that going on for 25 minutes, let's find our waveform here. You'd be looking from far out. You'd be looking at them KV spikes, and they're still very noticeable at 38. You'd be looking for an extremely high one that was, that was a misfire. And if you had that pulse sensor in there, you'd be able to time which one it is. But your actual burn line, you could still see the oscillations at 38 kilosample. You could still see kind of a burn line. You could see how blocky it gets when you expand it. But you wouldn't be trying to use this to find a miss. You'd just be looking for them spikes, which are still very, very usable. All right, so I mean, everything seems to work on it. I wish I had something with CAN bus or something like that to see if it could handle the speed, but this, other than the flicking, this is exactly like the S6. I mean, the Hscope responds great to it. Good tablet for it. And one last thing, I forgot, just see how it pulls up a save file. Oh, there we go. And pretty easy to zoom in on the waveforms. And yeah, I mean, I'd say there's no difference. The only difference is like the screen interface, things like that. It's pretty decent waveforms there. I mean, you could see the burn line pretty clear. This is on 300 kilosample a second. All right, guys, that's about all I got for you. I put that free tablet through the paces. And I mean, again, I get a lot of questions about what type of tablet. This doesn't even have a name. It has a squiggle and Android. I mean, even when you turn it on, no name comes up, just Android. It's got 4 gigabytes of RAM. That's the main thing that you want. You want to get 4 gigs, and that way you know you're safe. I have run it on 3 gig Samsungs, but I have not done like CAN bus. If it needs processing power, it might, crap out on the air. But, all in all, pretty good. I have to leave the link in the description because I got that free. So it's, for reviewing it. This is not the review, but I do have to leave the link there. But I'm telling you, any Android tablet over 4 gigs, you get a better deal, go for it. Another thing I want to talk about is the next one's going to be from Back Alley Basement. We're going to be making some leads and doing some tests down there. But these hand tech leads, don't buy them, man. I mean, they suck. I've have so many and I've gone through so many. The problem is, just like that, happens almost every time. They come screwed in. They're like the do-it-yourself ones with a screw, and they break off. The wire's so cheap. I soldered them back on, broke off again, flush with the insulation. So these are garbage. They're not even shielded good. I'll show you how to build some good ones, maybe get some better signals, less interference. Then, I mean, I thank you from the bottom of my heart for being with me and, watching the videos because, I'm up here by myself. Yeah. So it's good to have somebody to talk to, even if it's online with the same interest. But I'll show you how to make some good ones, show you an idea I have for, making good ones. I mean, like a different kind of system, because I'll tell you, I know I'm ranting and ranting. This should be part of the other video, but this part here, if you're going to make your own leads, if you got a 3D printer, you ought to print these and sell them. I don't have a 3D printer. I didn't get into that yet, but if you could print these out, put them on eBay or put them on Amazon, because I can't find any of these for sale, but I did come up with a workaround. These would be much more cost effective. But look for me in the basement next time, guys. Adios. All right, guys, this is how you helped make last year such a good year for me, and why I encourage you to make your own videos. YouTube gets behind you. This is number 876 out of 1934 for their 20th anniversary. They encourage you. They give you perks. They fed me Chipotle. They gave me Subway. They gave me his phone drive, which I'm going to need to get the videos off of this phone. It's pretty nice. I mean, they give you a lot of things. They gave me his clacker board. And that's about all I got, guys. Thanks a lot for watching. Adios.